What if I told you that right now, as you watch this, an object larger than Mount Everest is silently drifting through our solar system, and almost nobody is talking about it? Astronomers have named it 3IATLAS, but behind that clinical label hides something far more unsettling. Measuring nearly 11 kilometers wide, this interstellar traveler didn't come from our neighborhood. It came from deep space, from places older than our own galaxy. And its path is so precise that some scientists are starting to whisper the unthinkable, because this isn't the first time something like this has happened. Back in 2017, the world was caught off guard when a strange cigar-shaped rock called Oumuamua flashed across the night sky. At first, researchers thought it was just another cosmic fragment, a random shard of ice and rock tossed around the galaxy. But then the data started looking strange, too strange to ignore. It wasn't behaving like any comet we'd ever seen. No visible gas tail, no predictable arc, yet it mysteriously accelerated as though some hidden engine were pushing it along. Harvard's Avi Loeb made headlines when he suggested it might not be a rock at all, but rather a piece of alien technology, perhaps even a probe. The scientific community laughed, debated, argued, but deep down a question lingered. What if he was right? Fast forward 8 years, and now another interstellar visitor has appeared. Only this time it's not a small sliver slipping through our telescopes. Atlas is massive, deliberate, and eerily well-timed, arriving almost as if it were answering Oumuamua's silent call. Was that first object a scout? And is this one the real arrival? The possibility is chilling, and the more you learn about Atlas, the less coincidental it all begins to feel. In late 2017, something slipped into our solar system that shook the foundations of astronomy, not because of what it was, but because of what it refused to be. It was quickly given the name Oumuamua, a Hawaiian word meaning scout, or messenger from afar that arrives first. That name alone hints at how extraordinary its discovery was. For centuries, everything we studied in the skies, the planets, the moons, the comets, the asteroids, belonged here. They were part of our family, born from the same cloud of dust and gas that swirled together to form the sun billions of years ago. But Oumuamua was different. It wasn't local. It came from outside, from deep space, a visitor from beyond the protective bubble of our solar system. That alone would have made it historic, the first confirmed interstellar object ever detected by humans. But what really unsettled scientists wasn't just its origin, it was its behavior. When astronomers first caught sight of Oumuamua, it appeared to be elongated, maybe cigar-shaped, though later models suggested it could have been more like a flattened pancake, tumbling awkwardly as it moved. That tumbling in itself was strange, but not impossible. Rocks get battered and broken apart over billions of years, and odd shapes happen. What was harder to explain was the trajectory. As it whipped around the sun and began to head back out into the dark, it did something unexpected. It sped up. A comet, when heated by the sun, often does accelerate, because gas and dust get blasted off its surface like a rocket engine. But Oumuamua didn't leave a trail, no glowing tail, no burst of gas, nothing visible at all, and yet the numbers didn't lie. The thing was accelerating in a way that gravity alone couldn't explain. For mainstream astronomers, that presented a nightmare. Science thrives on patterns, on being able to say, this happens because of that. A comet behaves one way, an asteroid another. Oumuamua refused to play by the rules. It was like a guest who enters your home, sits down at your table, and refuses to explain who they are or why they're there. All you can do is watch, ask questions, and try to make sense of it. Naturally, theories poured in. Some suggested that Oumuamua was covered in a kind of reflective ice sheet, and the light from the sun created pressure that gently pushed it forward, like a sail catching wind. Others argued it was made of hydrogen ice, which would evaporate invisibly, giving it that subtle push without leaving a detectable trail. But even those explanations strained credibility, because no one had ever observed such a thing before. It felt like forcing a puzzle piece into a slot where it didn't really fit. Then came the more controversial voices. Harvard astronomer Avi Loeb, one of the most respected astrophysicists in his field, stepped forward with a theory that set the scientific world ablaze. What if Oumuamua wasn't natural at all? What if it was artificial? Some kind of alien probe or a fragment of alien technology? The shape, the acceleration, the absence of a tail, the timing, it all lined up, at least enough to raise eyebrows. Loeb argued that we shouldn't dismiss the possibility just because it made us uncomfortable. After all, science is supposed to follow the evidence, not dismiss it when it points somewhere strange. The backlash was immediate. Colleagues called the idea sensational, irresponsible, even damaging. But here's the thing. Once a possibility like that is out in the open, you can't unhear it. People start to look at the data differently. They begin to ask questions they didn't dare ask before. And those questions didn't just belong to scientists. The public too became captivated. Headlines screamed about an alien probe visiting our solar system. And while most of those headlines were exaggerations, they touched on a deeper truth. Oumuamua unsettled us because it was a reminder of how little we actually know about what's out there. For decades, science fiction has filled our imaginations with stories of ships from other worlds, scouts sent ahead of massive fleets, silent watchers drifting past our planet. Observing when Oumuamua arrived, it felt like those stories had suddenly stepped out of the realm of fiction and into reality. There's another detail that often gets overlooked but adds to the mystery. The timing of Oumuamua's arrival was uncanny. Humanity had just reached a point in history where our instruments were sensitive enough to catch an object like this. If Oumuamua had passed by just a few decades earlier, we would never have seen it. It would have come and gone, invisible to us, another anonymous traveler, lost in the dark. Instead, it showed up exactly when we had the tools to notice, as if it were waiting for us. Was that coincidence? Or was it something more deliberate? Skeptics will insist that coincidence is all it was, but coincidences stack up in strange ways, and Oumuamua's timing remains one of its most haunting traits. To put things in perspective, consider how vast the galaxy is. Stars are light years apart, and space is a near infinite void. For an object from another star system to wander directly into ours is already rare beyond comprehension. Yet in 2017 one did, and not just any object, one that defied classification, that moved in ways we couldn't easily explain. Astronomers estimate that billions of interstellar objects might be drifting around, relics of ancient systems long destroyed, but the odds of one intersecting our space so perfectly, in a way that made it detectable, are astronomically low. Which brings us back to that unsettling thought. What if it wasn't an accident? Even if we set aside the alien probe theory, Oumuamua forced us to expand our sense of possibility. If objects like this exist, it means that the boundaries of our solar system are more porous than we realized. We're not isolated. Debris, rocks, and perhaps other things we can't yet name are constantly passing through, slipping into our corner of the galaxy, brushing past us before vanishing again. The difference is that Oumuamua was the first one we caught in the act. It was the first whisper, the first clue that we're part of a much larger flow of material and mystery. And yet, for all the fascination, we were helpless. Oumuamua moved too fast, was too far away, and our technology too limited to send a probe to intercept it. By the time debates heated up, it was already fading into the black, leaving us with only scraps of data and an endless speculation. That's part of what makes it so powerful as a story. It left more questions than answers. Like a shadow slipping past a window, it gave us just enough of a glimpse to unsettle us, but not enough to understand. And maybe that's what made Avi Loeb's theory so irresistible. Not that it proved anything, but that it filled the void left by our lack of answer. Think about it. If you were designing a probe to slip into another solar system without being noticed, wouldn't you make it small, dark, hard to detect, with a trajectory that uses gravity to slingshot it along? Wouldn't you make it ambiguous enough that any civilization watching would argue endlessly over whether it was natural or not? That's the genius of Oumuamua. If it really was artificial, it gave us plausible deniability. Those who want to believe it was just a rock can keep believing. Those who see something more can't shake that feeling. In either case, it accomplished its mission to pass through unnoticed by most, but unforgettable to the few who truly paid attention. And perhaps that's the point. Maybe Oumuamua was never meant to reveal itself fully. Maybe it was just a test, a quiet hello, or a scout checking to see if anyone was watching. If so, then what comes next becomes even more important. Because in 2025, when another interstellar traveler appeared, one far larger, far stranger, and far more deliberate, it forced us to ask whether Oumuamua's story was ever really finished. When explorers set out into uncharted territory, they never send their entire fleet charging forward blindly. History tells us this over and over again. Whether it was ancient seafarers testing unknown waters with a single canoe, or empires dispatching scouts to survey hostile land before their armies advanced, the principle was the same. You send a small piece of yourself ahead to observe, to measure, to quietly decide if it's safe to proceed. That's why so many people, when reflecting on Oumuamua, couldn't shake the feeling that it resembled not just a rock but a messenger. Its very name, chosen in Hawaii, carried that symbolic weight, the scout, the one who arrives first. And when you look at it through that lens, the unsettling details suddenly take on a new coherence. The scout doesn't reveal everything. It doesn't linger long enough to be captured. It slips in quickly, gathers what it needs, and disappears. That is precisely what Oumuamua did. The idea of a scout theory isn't science fiction pulled from a paperback novel. It's a logical extrapolation of how intelligent species would likely behave if they had the means to explore beyond their home systems. Even humanity, still bound to Earth and its orbit, already follows the same pattern. Before sending astronauts to the moon, NASA sent robotic probes. Before attempting to land rovers on Mars, orbiters and flybys paved the way. We never risk everything on the first attempt. We dip our toes, we test the waters, and only then do we commit. If this principle holds for us, why wouldn't it hold for a civilization far older, far more advanced, and perhaps unimaginably cautious? When Oumuamua passed through our system, it behaved in ways that could be explained as reconnaissance. It came from above the plane of the planets, swooping in at an unusual angle, as if surveying not just one orbit but the entire arrangement of our system. It passed relatively close to Earth's orbital path, within a range that suggested careful aim rather than random luck. Then, as soon as it completed its sking around the sun, it accelerated away, vanishing into the dark before we could get more than fleeting glimpses of its structure. That sudden acceleration, so baffling to scientists, makes perfect sense under the scout theory. It's the kind of maneuver you'd expect from a craft designed to minimize risk, to avoid capture, and to guarantee its escape. Even the uncertainty about Oumuamua's shape plays into the same narrative. Some telescopes suggested it was a long, cigar-shaped shard. Others pointed to a thin, flattened disk tumbling end over end. Both shapes could serve practical functions if it were artificial. A cigar-like body would be aerodynamic, reducing drag through interstellar dust, while a flat sail-like structure could harness radiation pressure for propulsion. The ambiguity itself, the fact that we couldn't pin down its true form, might have been part of the design, enough to confuse, to defy categorization, to leave us arguing long after it was gone. That's exactly what a scout would want. Critics of the theory argue that it leans too heavily on human analogies, that projecting our own strategies onto hypothetical alien civilizations is reckless. But those critics forget how universal some strategies are. Predators on Earth, separated by millions of years of evolution, still converge on similar hunting tactics because they work. Birds, fish, mammals, all send scouts, all test conditions before diving into danger. If nature on our own planet favors reconnaissance, why wouldn't nature in the cosmos? Efficiency tends to repeat itself across scales. What works in the jungle might also work in the galaxy. Another eerie detail that supports the scout theory is how Oumuamua seemed almost indifferent to being seen. If it were truly just a rock, its indifference would mean nothing. But if it were something more, it's possible that its designers expected us to notice. Perhaps they even wanted us to notice. After all, in 2017 humanity was at a crossroads in its technological development. We had built telescopes capable of spotting faint interstellar visitors, but we lacked the propulsion systems to chase them. In other words, we could see, but we couldn't act. For a cautious scout, that's the perfect time to appear, when the locals are smart enough to detect you, but still too primitive to interfere. That window of vulnerability is exactly when you'd want to make first contact, or at least first observation. And here's where things get even more unnerving. If Oumuamua was indeed a scout, then its job wasn't to impress us or to reveal its secrets. Its job was to gather information and send it back. What kind of information? The obvious answer would be data about our star, our planets, and perhaps even about Earth itself. Spectral readings could reveal our atmosphere, our levels of pollution, our radio signals. A close pass could map our orbital mechanics with exquisite precision. From just one swoop, an advanced craft could learn more about our world than we've learned about exoplanets in decades of searching. And if Oumuamua was transmitting, even in ways invisible to us, then whoever sent it already knows we're here. They already know we're intelligent. They already know we're watching. Skeptics will point out that we have no evidence of transmissions, no confirmed signals from Oumuamua. That's true, but absence of evidence is not evidence of absence. If the craft used narrow beam communication directed away from Earth, we'd never detect it. If it relied on exotic forms of communication beyond our current understanding, it could be buzzing with signals, and we'd be deaf to them. The point is not whether we detected a message. The point is whether Oumuamua needed to leave one at all. Perhaps its mere presence was the message. Perhaps the signal was in the trajectory itself, a rock that doesn't act like a rock, arriving just as we're capable of noticing. A subtle knock on the door, letting us know we're not alone. It's tempting to dismiss this as paranoia, to retreat into the comfort of natural explanations. Hydrogen ice, dust-driven acceleration, odd shapes formed by cosmic violence. These are the safer answers, the ones that let us sleep at night. But history shows us that new discoveries often look impossible until they become obvious. Once people believed stones falling from the sky was superstition, then meteorites were proven real. Once the idea of invisible waves carrying voices through the air sounded like madness, then radio transformed civilization. Perhaps today the idea of alien scouts feels absurd. Perhaps tomorrow it won't. Of course, the scout theory raises as many fears as it does hopes. If Oumuamua was a scout, then it wasn't here alone. It was the first, not the last. Behind every scout lies the possibility of a fleet, a wave, a second act that reveals the purpose of the first. That's why, when 3IATLAS appeared years later, larger, slower, and more deliberate, people began to connect the dots. What if Oumuamua was the advance party, the quick glance, the subtle probe? And what if Atlas was the response, the follow-up? The one that doesn't just look but lingers. Suddenly the narrative of a random rock feels incomplete. Suddenly we're looking at a pattern. The scout theory doesn't claim to have all the answers. It doesn't prove Oumuamua was artificial. What it does is remind us that the universe doesn't owe us easy explanations. Sometimes the simplest answer is also the most unsettling, and sometimes the strangest theories turn out to be the most accurate. If we've learned anything from our own history, it's that scouts always mean something more is coming. The real question is whether we're ready for what comes next. When news of 3IATLAS first surfaced, it didn't carry the same immediate impact as Oumuamua. There were no screaming headlines about aliens or strange shapes, no bold pronouncements about hidden technology. It seemed at first like just another blip in the endless stream of discoveries, a curiosity for astronomers rather than a mystery for the world. But as the data came in, the story changed. And what emerged was not just another interstellar object, but something so massive, so deliberate, and so unnervingly well-timed that even the most skeptical voices began to hesitate. This was no fleeting shard tumbling past us like a vagabond traveler. This was something altogether different, larger, slower, more intentional, and in many ways more ominous. Atlas is estimated to be about 11 kilometers wide, which makes it nearly the size of Mount Everest if you stretch that mountain sideways across the void. To grasp just how large that is, consider that the asteroid believed to have wiped out the dinosaurs 65 million years ago was around 10 kilometers across. That single rock changed the course of life on Earth forever. Now imagine an object of similar scale drifting through our solar system, not just some anonymous fragment from the Oort cloud, but an interstellar visitor born in a place so ancient and so distant that even the stars we see at night can't tell its story. When astronomers first calculated its size, there was a collective pause, a moment when the numbers felt too large, too unlikely to be true, and yet the data held firm. Atlas was massive, far bigger than Oumuamua, and its scale alone demanded that we pay attention. But size was only the beginning. The way Atlas moved was even more puzzling. Unlike Oumuamua, which darted into our system like a startled bird, Atlas seemed to glide with purpose. Its path was astonishingly smooth, calculated with a precision that looked almost engineered. The orbit it traced was retrograde, moving against the general flow of planets and debris in our system. To a casual observer, that detail might sound trivial, but to scientists it was a red flag. Natural objects over billions of years tend to settle into predictable flows, orbiting in roughly the same direction as the sun's rotation. For Atlas to arrive on a retrograde orbit, almost perfectly aligned to slice through our system in the most efficient way possible, was like watching someone swim upstream against the current with flawless technique. It didn't look random. It looked chosen. Even more unsettling was the timing. Atlas appeared almost exactly 8 years after Oumuamua's passage. In cosmic terms, 8 years is nothing, a blink of an eye. Yet here we were, confronted with another interstellar object of wildly unusual characteristics arriving just as the memory of the first was beginning to fade. For those who had already entertained the scout theory, the coincidence was too much to ignore. If Oumuamua was the quiet knock on the door, Atlas felt like the door itself creaking open. One arrives small and ambiguous, just enough to test the waters. The other arrives enormous and undeniable, carrying with it a sense of escalation. The behavior of Atlas also confounded scientists in ways eerily reminiscent of Oumuamua. Early observations showed it releasing dust. Yet strangely, no gas could be detected. Normally a comet-like body sheds both dust and gas as it heats up, with the gas propelling the dust outward, but Atlas seemed to break that rule. Dust drifted from its surface without the accompanying signatures of vaporized ice, leaving astronomers scratching their heads. Was it breaking apart? Was it camouflaging itself? Or was it composed of materials unlike anything we had studied before? For a time, the scientific community bent over backward to explain it, offering models of ultra-fragile structures, unusual chemical compositions, or mechanisms we had never observed. But underneath the careful papers and measured statements was a growing unease. Atlas wasn't behaving the way it should. When researchers analyzed its composition, the findings only deepened the mystery. About 70% of its makeup appeared to be dark organic compounds, complex carbon-based material that could, under the right conditions, serve as the building blocks of life. The rest was mostly water ice, but ancient ice, kind formed billions of years ago, in the earliest days of galactic history. In other words, Atlas wasn't just old. It was primordial, a relic from a time long before our solar system even existed. Its origins were traced back to what's known as the thick disk of the Milky Way, a region populated by stars and remnants more than 10 billion years old. To hold a fragment of that age within our instruments was to hold a piece of galactic prehistory, something that had been traveling the void since before Earth was even a thought. That alone would make it monumental. But when you combined its size, its trajectory, and its timing, the picture began to feel less like natural chance and more like design. What unsettled many was how deliberate it all seemed. If you were to imagine what an intelligent species might send into another solar system, you might picture something just like Atlas, massive enough to endure the journey, slow enough to linger and collect data, composed of materials that could blend seamlessly with natural cosmic debris. On the surface, it would look like a comet. Beneath that surface, who could say? And if Oumuamua had been the scout, the messenger, then perhaps Atlas was the observer, the recorder, the one tasked with a longer and closer look. The transition from the first to the second began to look less like coincidence and more like sequence. This is where history becomes an eerie mirror. Explorers rarely send just one scout. A single reconnaissance mission is valuable, but it's only the beginning. Once the scout returns, or once it sends back word, something larger almost always follows. A ship, an army, a fleet. The scout clears the way, and then the main force steps in to gather deeper intelligence, or to prepare for contact. Throughout human history, this pattern repeats again and again, from ancient empires probing enemy borders to modern nations sending drones before deploying troops. The unsettling question is whether we're witnessing the same strategy played out on a cosmic scale. Oumuamua as the advanced scout, and Atlas as the main reconnaissance force. The silence surrounding Atlas in popular media has been strange in its own right. Oumuamua dominated headlines, yet Atlas, despite being far larger and more enigmatic, has slipped by with far less fanfare. Perhaps this is because the narrative of alien visitor had already been spent on the first, and scientists were wary of stirring controversy again. Or perhaps it's because Atlas is simply harder to explain away. The less you talk about it, the less people ask uncomfortable questions. But ignoring it doesn't make it less real. It's still there, drifting with uncanny precision through our system. Its presence undeniable, its purpose still a mystery. And that's the point where the imagination begins to fill in the gaps. What if Atlas isn't just a rock, but something more? What if its dust emissions are not the chaotic shedding of a comet, but a controlled release, a kind of exhaust or camouflage? What if its retrograde orbit isn't an accident but a deliberate choice, designed to optimize its survey of our star and planets? What if its composition, rich in organic material, isn't just a coincidence but a clue to its intended function? Suddenly the line between natural and artificial blurs. Suddenly the scout theory feels less like speculation and more like a chilling possibility. When people talk about coincidence, they often forget how thin the margin of chance really is. The galaxy is vast beyond comprehension, filled with billions of stars and trillions of rocks. The odds of two unusual interstellar objects crossing paths with our tiny solar system within a single decade are so small they border on the absurd. Yet here we are, living in the era when it happened, not centuries ago, not centuries from now, but precisely when our species has just developed the eyes to see it. Oumuamua was strange enough. Atlas is stranger still. Together they form a pattern we can't easily dismiss, and the story of that pattern is only beginning to unfold. When astronomers speak of orbits, they usually speak of chaos tamed into patterns. Planets, comets, and asteroids all obey the same gravitational laws, and their paths, while varied, tend to fall into familiar rhythms. Over billions of years, the swirling disk of dust and gas that gave birth to our solar system imposed order. Most objects circle the sun in the same direction as its rotation, within the same flattened plane, as though they were all dancers moving in unison to a song older than time itself. That's why when something cuts across that choreography, when a body streaks in from a steep angle or against the current, it raises questions. Atlas didn't just raise questions, it raised alarm. Its trajectory was too perfect, too efficient, too deliberate to be dismissed as random wanderings of a cosmic drifter. It was the kind of path you'd expect if someone had plotted it carefully, calculated it down to the smallest decimal, and then set it loose with precision. From the moment its orbit was mapped, Atlas stood apart. Most interstellar objects we expect to find should wander through space with no regard for our little corner of the galaxy. They should arrive at odd inclinations, cutting messy lines through the ecliptic plane, passing at distances that feel like near misses or irrelevant flybys. Atlas, however, entered on a retrograde orbit so clean and aligned that it almost seemed intentional. Retrograde in itself is rare. It means moving against the grain, swimming upstream through the flow of everything else. But Atlas wasn't just retrograde, it was positioned in such a way that its path sliced neatly through our solar system, grazing close enough to study but far enough to avoid catastrophic collision. To anyone studying the numbers, it didn't look like chaos, it looked like choreography. Some scientists compared it to the maneuvers spacecraft use when navigating complex gravitational systems. When we send probes to other planets, we don't fling them randomly into space and hope they arrive. We calculate slingshots, gravitational assists, precise angles that maximize efficiency while minimizing fuel use. A fraction of a degree off, and the mission fails. But get it right, and a small craft can travel billions of miles with remarkable accuracy. That's what made Atlas's orbit so unnerving. It mirrored the kind of planning we associate with intelligence, not accident. It was as though Atlas had been guided into its path by something or someone with a clear objective in mind. Critics argued that retrograde orbits can happen naturally, that interstellar debris doesn't care about the neat order of our system. And technically they're right. Chaos does occasionally throw a stone across the stream, but probability matters. Out of the countless directions Atlas could have approached from, it happened to choose one that maximized its visibility to our instruments, one that placed it on a stage where humanity was guaranteed to notice. Add that to the fact that it arrived less than a decade after Oumuamua, and the word coincidence begins to feel paper-thin. The odds of one unusual interstellar visitor are already astronomical. The odds of two, both carrying anomalies in their behavior, both timed perfectly with our developing technology, and one following the other in a suspicious sequence, strain credibility. The orbit wasn't just strange, it was suspiciously meaningful. There is also the matter of speed. Oumuamua raced through our system so fast that it was gone before we could even blink. Atlas, in contrast, moved slower, almost leisurely by comparison, giving us more time to observe it. Slower movement also means more detailed data could be gathered from its interactions with solar radiation, gravitational forces, and planetary alignments. It was as if Oumuamua had been the flash, the quick reconnaissance, and Atlas was the sustained survey, taking its time to soak up the details. Speed, combined with trajectory, made the entire arrival feel staged, like two acts of the same play. The scout runs in and out quickly, The follow-up lingers. The sequence is too consistent with patterns we already understand from our own exploration to ignore. Even the efficiency of Atlas's trajectory drew comparisons to engineered missions. Natural bodies wander, drift, and often waste energy in chaotic arcs. Atlas did not. Its path, while technically explainable by physics, seemed to maximize observational opportunities, passing near enough to be detected, but not near enough to raise panic, skimming through the solar system on a path that would allow it to sample gravitational fields, solar winds, and planetary alignments. It looked in many ways like a survey mission, and that possibility haunted those willing to think outside the box. If someone were testing our system, measuring its stability, mapping its planetary layout, this is exactly the trajectory they'd designed. The silence around Atlas in mainstream circles may stem partly from this. With Oumuamua, scientists could cling to plausible deniability. It was small, fast, and ambiguous enough that you could argue endlessly about hydrogen ice, reflective surfaces, or natural oddities. Atlas, however, was harder to dismiss. The sheer scale, the composition of organics and ancient ice, the dust without gas mystery, and now this precision trajectory, it was too much to sweep under the rug. To entertain the possibility that Atlas was not random was to open a door many weren't ready to open. And so, rather than confront the trajectory head-on, much of the discussion softened, framing it as an interesting anomaly rather than a red flag. Yet those who truly studied the orbit could see the unsettling implications. Imagine if the roles were reversed. Suppose humanity had developed interstellar probes capable of crossing to another star system. Would we send them at random, letting them drift without purpose? Of course not. We'd calculate every detail, ensuring the craft approached in ways that maximized data collection while minimizing risk. We'd choose paths that avoided planetary collisions but provided the clearest possible survey of the system. That is precisely what Atlas appears to be doing. If it were one of our probes, its trajectory would make perfect sense. The disturbing question is whether that sense applies to us, or to something or someone else entirely. And yet, perhaps the most unsettling aspect isn't the trajectory itself, but what it implies about intent. A random orbit tells you nothing. A precise orbit tells you everything. It tells you someone was aiming, someone was planning, someone was watching closely enough to make sure the path achieved its goal. Whether Atlas is natural or artificial, the fact remains, it acts like something with purpose. And purpose, when it comes to visitors from beyond the stars, is a word heavy with consequence. If Atlas was guided, then who guided it? And if it was not, then why does it behave as though it was? The orbit alone keeps the debate alive, refusing to let the mystery settle into a simple answer. What unsettles most is not that Atlas exists, but that it exists in a way that looks too clean, too deliberate, too intelligent. It's one thing to accept random wanderers brushing against our solar system. It's another to accept wanderers that appear precisely when we're capable of seeing them, arriving on trajectories that look designed rather than accidental. The orbit of Atlas is less a path through space than a signature across the sky, a line written for us to read. Whether we choose to read it as natural or artificial is our choice. But either way, the message lingers. Something came here, and it came here in a way that feels far too perfect to ignore. Patterns define us. They shape how civilizations rise, how they expand, and how they reach beyond the limits of what they know. To understand what may be unfolding with these interstellar visitors, we don't need to imagine exotic alien logic. We only need to look back at our own history. Again and again, when humans encountered the unknown, we followed predictable rhythms. And when we place those rhythms beside Oumuamua and Atlas, the parallels are almost too sharp to dismiss. Consider the great age of exploration on Earth. When European powers first dreamed of reaching distant lands, they didn't launch their entire fleets across uncharted waters. They began cautiously, dispatching scouts and individual ships to probe coastlines, to map rivers, to record currents and winds. These early voyages weren't invasions, they were reconnaissance. Their mission wasn't to conquer, but to learn, to decide whether larger expeditions would be worth the risk. The same principle played out in military history. Armies never charged blindly into unknown territory. They sent small detachments, advance guards to test defenses, to gather intelligence, to bring back knowledge before the main force advanced. Scouts meant survival, they meant control, and more often than not, they dictated the fate of what followed. Now place Oumuamua in that context. It arrived suddenly, small and elusive, staying just long enough to leave questions but not answers. That is the exact footprint of a scout. It slipped in and out of our system so quickly that by the time we realized what we were looking at, it was already gone. Its strange acceleration, its lack of a visible tail, its ambiguous shape, all of it left us guessing, debating, unable to pin it down. But perhaps that was the point. A scout doesn't reveal its full hand. It observes, it collects, it ensures the coast is clear. It doesn't need to leave us proof. It only needs to leave us wondering. Then, years later, Atlas appeared, larger, slower, deliberate. If Oumuamua was the whisper, Atlas was the presence that couldn't be ignored. And once you align these two within the framework of history, the pattern is familiar. First the scout, then the surveyor. First the small probing act, then the larger, undeniable presence. This sequence isn't random. It's the same dance humanity has performed for thousands of years whenever the unknown lay ahead. Even in nature, the same principle applies. Wolves send lone scouts ahead of the pack to test prey before committing to a hunt. Birds send a few individuals to survey food sources before the entire flock moves. The logic is universal. Risk the few to protect the many. Gather information first, act later. If these patterns emerge across biology and human society, why would they not also emerge on a cosmic scale? Intelligence, after all, tends to evolve towards strategies that work, and reconnaissance works. Skeptics may argue that applying human analogies to cosmic visitors is misguided, but patterns don't belong to humans alone. They belong to survival. If a civilization advanced enough to send probes across interstellar space exists, they would have every reason to behave cautiously. Space is dangerous, and any unknown star system could harbor risks. Imagine if humanity finally developed the technology to send a probe to another star. Would we send a massive, crude vessel first? Of course not. We'd send something small, perhaps even ambiguous, designed to collect data quietly before exposing ourselves further. And once that probe returned useful information, or transmitted it across the void, we'd follow with something larger, more deliberate, something meant to stay longer and gather deeper knowledge. That is exactly the sequence we seem to be witnessing. The unnerving part of this pattern isn't just what it suggests about intent, it's what it suggests about the future. In every case where scouts appear, something follows. The Spanish scouts who mapped coastlines were followed by conquistadors. The advance guards of armies were followed by the main battalions. The lone ship testing foreign currents was followed by fleets carrying settlers, merchants or soldiers. If Oumuamua was the scout and Atlas the surveyor, what comes next? If history is any guide, the next step is escalation. The arrival of something larger still. That doesn't necessarily mean hostile fleets or invasions, but it does mean presence. It means whoever or whatever sent these visitors is playing a long game, one we may only just be glimpsing the first moves of. It's important to note how subtle the parallels are. In our own history, scouts were rarely recognized for what they were until much later. A small boat landing on an unknown shore might look like curiosity, not the first act of colonization. A few soldiers skirmishing near borders might seem like harassment, not preparation for war. Only in hindsight does the pattern become obvious. The same could be happening now. Oumuamua passed and left us puzzled. Atlas arrived and forced us to think hard. When historians of the future look back, if humanity survives long enough, they may see this decade as the decade the pattern revealed itself, the moment the scout and the surveyor laid the groundwork for what came next. There's also the psychological dimension. When scouts appear, they test not only the environment but the inhabitants. A scout boat landing on a foreign shore observes how the locals react. Are they hostile? Are they curious? Do they have weapons? Do they ignore the landing altogether? That information can be as valuable as any map. Oumuamua may have been testing us in the same way. It came close enough to detect whether intelligent eyes were watching. And we were. Telescopes tracked it. Scientists debated it. The media exploded with theories. If it was indeed a scout, then its mission succeeded. It confirmed that intelligence exists here, that we are capable of noticing, and that we are already imagining what it could mean. That alone would have been enough to trigger a second act. Atlas. What makes Atlas even more significant in this pattern is its scale. A scout is small and quick. A surveyor, by contrast, is built for endurance. Atlas is massive, rich in complex materials, and slow enough to linger. This matches perfectly with the shift from initial reconnaissance to deeper observation. A large, resilient probe or even a disguised vessel would be designed to weather the journey and remain intact long enough to perform detailed study. Its trajectory, its strange dust emissions, its composition, all of it feeds the idea that Atlas isn't just passing through, it's staying long enough to watch, to listen, to record. In our history, scouts didn't just pave the way, they marked the beginning of relationships that would change civilizations forever. Some of those relationships were devastating, leading to conquest and collapse. Others led to exchange, trade, and transformation. The unsettling truth is that we don't yet know which pattern we're about to follow. Another layer of this historical analogy is the role of ambiguity. Scouts rarely announce themselves. They often blend into the environment, pretending to be something harmless, something ordinary. A ship might pose as a merchant vessel. A spy might pose as a traveler. Their mission depends on being underestimated. Isn't that exactly what we see with Oumuamua and Atlas? Both present themselves as natural rocks, comets, or fragments. That camouflage is perfect because it allows most of the scientific community to dismiss them as curiosities, not threats. And yet, those who look closer can't ignore the anomalies. This duality, appearing harmless while behaving suspiciously, is precisely the strategy scouts have used for millennia. The scariest part of all is that the pattern feels familiar not just because of history, but because of instinct. Something deep inside us recognizes the sequence. We've lived it too many times before, across too many centuries, for it to feel coincidental. Scouts don't arrive without purpose. Patterns don't repeat without reason. And once you accept that Oumuamua and Atlas may not be isolated accidents, the implications unfold like a story we already know too well, one where the first arrivals are never the last. When Atlas was first observed, astronomers expected it to behave like a comet. That meant ice should sublimate when heated by the sun, vaporizing into gas that streams outward, dragging dust particles with it to form a glowing tail. This is cometary physics 101, the predictable choreography that countless icy wanderers in our system have followed. Yet Atlas betrayed that expectation in the most perplexing way. Dust drifted off its surface, but gas never revealed itself. It was as though the creature exhaled smoke but no breath, a phantom coughing dust into the void while hiding the mechanism that powered it. For scientists trained to identify chemical signatures, this was maddening. Gas leaves fingerprints, spectral lines that can be detected even from millions of miles away. But no matter how carefully they looked, the usual signatures of water vapor, carbon dioxide, or carbon monoxide were absent. Dust without gas, a contradiction, a violation of what should be possible. At first, many chalked it up to observational error. Perhaps the instruments weren't sensitive enough. Maybe the gas was there, just hidden beneath the limits of detection. But repeated observations confirmed the pattern. Dust, yes. Gas, no. The dust cloud grew, faint but undeniable, while the gas remained invisible. If Atlas had been smaller, perhaps the puzzle could have been dismissed as some odd quirk. But at 11 kilometers across, this wasn't a trivial anomaly. It was a fundamental challenge to what we thought we knew about cometary bodies. Dust, by itself, has no reason to escape a nucleus of that size. Gravity, weak though it may be on such a body, should still keep particles clinging to the surface, unless something gives them a push. Gas is usually that push. Without it, how could Atlas be shedding? Some researchers suggested the dust might be mechanically fractured off, triggered by thermal stress or surface cracking. Imagine the rock expanding and contracting as it warmed, pieces breaking loose, drifting into space without the help of sublimated gases. But this explanation, while neat, left holes. The dust cloud was too consistent, too sustained, to be the result of random surface breakage. Others proposed exotic materials that could sublimate invisibly, substances we had never observed before. Yet this, too, stretched credibility. Every known volatile leaves a signature somewhere on the spectrum. For Atlas to shed dust with no detectable gas implied either that it was made of materials wholly alien to our knowledge, or that something else entirely was happening. And this is where the unsettling theories began to creep in. What if the dust emission wasn't natural at all? What if it was controlled, regulated, or even deliberate? From one perspective, Atlas's dust cloud could function as camouflage. A faint halo of dust could soften its optical profile, scattering light and disguising its true shape. If we were looking at a probe or an engineered structure, dust would be the perfect mask, letting it masquerade as an ordinary comet while hiding the details beneath. This is not so far-fetched as it might seem. Even on Earth, militaries use chaff clouds of reflective particles to obscure their aircraft from radar detection. A cosmic equivalent, using dust instead of metallic strips, would serve a similar purpose: confusion, misdirection, concealment. Another possibility is that the dust was waste. Any machine, no matter how advanced, produces byproducts. If Atlas was some kind of artificial object, the dust could represent discarded material, vented deliberately to prevent buildup. Think of a submarine releasing ballast, or a spacecraft purging fuel residue. To us it appears as mysterious shedding. To whoever operates it, it may simply be maintenance. The lack of gas becomes less puzzling in this light. Gas implies sublimation, a natural process. Dust alone might be evidence of something non-natural. Skeptics, of course, resisted these darker interpretations, striving for a natural explanation that wouldn't open the door to science fiction. They argued that the dust cloud might have been an illusion of observation angles, that subtle outgassing processes might have escaped detection, or that Atlas was simply composed of materials too unusual to fit our categories. But the discomfort was clear. Dust without gas was not just a small mystery, it was a gaping hole in our understanding. Every time the data was revisited, the same contradiction stared back. What makes the dust problem even more unnerving is how it fits into the broader pattern of anomalies. One anomaly can be dismissed. Two anomalies can be stretched into coincidence. But when anomalies stack, the strange trajectory, the timing after Oumuamua, the unusual composition, and now dust without gas, they start to look less like errors and more like evidence of something intentional. Atlas wasn't just one mystery. It was a tapestry of mysteries, each thread pulling at the next. And the dust emission, quiet though it seemed, became one of the strongest hints that this object wasn't behaving like any natural visitor should. Think about how a scout or surveyor might behave if disguised as a comet. The disguise must be good enough to satisfy most observers, but not so perfect that it draws suspicion. Dust emission would be a clever tool. Too much gas, and the object would look like a classic comet, bright and flamboyant, a spectacle for the sky. Too little, and it would look like a dead asteroid. Dust without gas places it in an uncanny valley, close enough to cometary behavior to be accepted, but strange enough to keep experts guessing. It muddies the waters, ensuring no consensus forms, no single story dominates. That kind of ambiguity is protection. The more we argue over what it is, the less certain we are about what to do. There's also the question of symbolism. Dust is ephemeral, fleeting, almost ghost-like. A trail of dust marks presence but not permanence. If Atlas were meant as a message, dust without gas could be that message. We are here, but we do not reveal ourselves. A whisper rather than a shout. A signature that cannot be traced to its source. In the same way that Oumuamua's silence spoke volumes, Atlas's dust spoke in riddles. We could see the effect, but not the cause. We could watch the shedding, but not understand the mechanism. It was the perfect cosmic tease, one that left us straining for answers while ensuring we found none definitive. The implications of the dust mystery ripple outward. If Atlas is natural, then it represents a category of object we've never catalogued before, a new class of interstellar body that defies the rules of comets and asteroids alike. That alone is monumental, rewriting the textbooks of planetary science. But if Atlas is not natural, then the dust without gas becomes something else entirely. Evidence of concealment, of design, of intent. Either way, it forces us to confront the uncomfortable truth that we do not yet understand what is moving through our skies. In many ways, this mystery mirrors the earliest moments of human exploration. When indigenous peoples saw the first European ships arrive, the sails and masts were confusing, unlike anything in their experience. To them, those sails were strange shapes on the horizon, perhaps supernatural, perhaps natural, impossible to classify. Only later did they realize those shapes carried intent, carried purpose. We may be staring at Atlas's dust the same way, seeing only a strange behavior without yet grasping what it conceals. And by the time we understand, it may be too late to change what follows. The dust without gas is more than a scientific puzzle. It is a riddle wrapped in shadow, a clue left in plain sight. Whether it is a natural anomaly or an artificial disguise, it forces us to admit that something extraordinary is happening, something that challenges our assumptions about what the universe delivers to our doorstep. Oumuamua left us questions. Atlas left us dust, and somewhere within that dust lies the possibility that we are not just observers of cosmic chance, but participants in a drama we have only begun to recognize. When scientists finally began to piece together what Atlas was made of, the results painted a portrait both fascinating and unsettling. At first glance, its composition seemed like the kind of thing we might expect from a distant interstellar wanderer, a mixture of dark organic compounds and ancient water ice. But the closer they looked, the stranger the picture became. Roughly 70% of Atlas appeared to be made of complex carbon-rich material, the kind of tar-like substances that absorb light and make objects appear darker than coal. The remaining 30% seemed to be water ice, but not the fresh ice of a comet recently tugged from the Oort cloud. This was ancient ice, old beyond comprehension, formed in the primordial days of the galaxy itself, billions of years before Earth even coalesced. In other words, Atlas wasn't just big. It wasn't just mysterious in its orbit or its dust. It was also staggeringly old, a relic of cosmic history, older than our sun, older than the planets that circle it, older even than many of the stars we see today in the night sky. This in itself would be monumental. Imagine holding in your hands a stone from Earth's first days, a rock that had survived untouched since the planet's birth. Now multiply that by 1,000 and place it in the context of the galaxy. That's what Atlas represents. A time capsule from the thick disk of the Milky Way, a region populated by ancient stars formed in the galaxy's early years. Astronomers believe Atlas began its journey there, flung into interstellar space perhaps 10 billion years ago, drifting in darkness, until it found its way to us. To even speak the number 10 billion is to stretch human comprehension. Civilizations rise and fall in mere centuries. Our entire species has existed for only a fraction of a million years. Yet this object has been traveling for 10 billion, silent, patient, eternal. And here's where the unsettling thought takes hold. If Atlas is a natural relic, it is a marvel, a scientific treasure that could rewrite our understanding of the galaxy's evolution. But if it is not purely natural, if some part of it is engineered, then its age and composition take on a chilling new meaning. Imagine an object constructed in the earliest days of the galaxy, sent forth by a civilization that may no longer even exist, built to endure not just centuries but billions of years. What kind of intelligence thinks in such scales? What kind of beings build machines that can survive the birth and death of stars, the collision of galaxies, the endless churn of cosmic time? If Atlas is artificial, then it is not just a visitor. It is a monument, proof of a civilization so advanced it could outlast time itself. Even the organics within Atlas carry unsettling implications. Organic compounds in astronomy usually suggest prebiotic chemistry, the raw ingredients of life. They form naturally in many places, created in the cold darkness of interstellar space when simple molecules like methane and ammonia are bombarded with radiation. On their own, they are fascinating but not miraculous. But in the case of Atlas, their abundance raises questions. 70% is an overwhelming fraction, far greater than what we see in most comets or asteroids. Why so much? Was Atlas a carrier of organic material, a cosmic seed ship of sorts, designed to scatter the ingredients of life wherever it traveled? Or was it something else, an ancient repository, deliberately packed with material that could endure across epochs? The line between natural chemistry and deliberate design grows blurry when the numbers stretch this far from the norm. The water ice adds its own layer of mystery. Water, we know, is the foundation of life as we understand it. Finding it in Atlas should not be surprising, yet its condition tells a deeper story. This is not the volatile, fragile ice of comets we've studied in our system. This is ancient, crystallized ice formed in environments alien to our own, hardened by 10 billion years of survival. In one sense, this makes Atlas a time capsule, preserving a record of the galaxy's earliest chemistry. But in another sense, it makes it something far stranger, a vessel that has carried both water and organics across billions of years, delivering them wherever it passed. To call it accidental feels inadequate. To call it deliberate feels inevitable. There are those who suggest Atlas might represent something like panspermia on a galactic scale. Panspermia is the theory that life, or at least the building blocks of life, can spread from world to world via comets, asteroids, and other celestial debris. If true, then life on Earth may not have started here at all. It may have been seeded by material that arrived from elsewhere. Atlas, with its vast reservoir of organics and ice, seems tailor-made for such a role. It could be a natural delivery system, carrying the seeds of life across the galaxy. But what if it's more than natural? What if it was designed to do just that? A civilization advanced enough to think in billions of years might decide to scatter life through the stars, ensuring their legacy would outlast their existence. If Atlas is such a vessel, then we are not just studying an interstellar object, we are studying the fingerprints of galactic gardeners. And yet, not everyone agrees on this interpretation. Many insist that the composition is exactly what one might expect from an interstellar comet, albeit a particularly large and ancient one. They argue that the abundance of organics, while unusual, falls within natural variation, and that the age of the ice is exactly what one would expect for an object formed in the thick disk. From this perspective, Atlas is not a messenger or a monument, but simply a relic, a frozen stone carrying the scars of cosmic history. But even within this view, the significance cannot be overstated. Atlas is unlike anything we have studied before, a direct sample from the earliest days of the galaxy, a piece of matter that predates the sun itself. To dismiss it as ordinary is to miss its grandeur. Still, the debate lingers, because composition is not an isolated fact. It must be read alongside everything else we know. The trajectory, the dust without gas, the timing after Oumuamua, the sheer size, all combine to create a puzzle that resists simple answers. Composition is another piece of that puzzle, and rather than settling the mystery, it deepens it. Natural or artificial, Atlas is not ordinary. It is too old, too rich in organics, too well preserved to be dismissed, and the more we learn about what it's made of, the more we realize how little we understand about why it is here. There is also the symbolic weight of its ingredients. Water and organics, the very essence of life, are what define Atlas. It is in many ways the embodiment of potential. If you were to design a vessel meant to capture the attention of a young, developing civilization, you might build it out of these very things. You might make it a beacon of possibility, a reminder that life is not confined to one world, one system, one chance. In this way, Atlas becomes more than an object. It becomes a question. Is life a rare accident, or is it a deliberate gift scattered across the stars? By existing as it does, Atlas forces us to confront that question, and the answer may change how we see ourselves forever. In the end, what Atlas is made of may be the most important clue of all, because whether it is a natural relic of the galaxy's birth or a deliberate artifact of an ancient intelligence, its composition speaks of endurance, of survival, of life carried across unimaginable distances. It is a vessel of memory, holding within it the chemistry of creation, waiting to be found. And now that it has been found, now that it has crossed paths with us, we are left with the task of interpretation. Is it an accident of cosmic history, or is it a deliberate signpost, pointing us toward a future we can barely imagine? For every discovery there comes the inevitable battle between explanation and imagination. With Atlas, that battle has reached a fever pitch. On one side stand the scientists who insist that everything we see, its vast size, its strange dust emissions, its perfect trajectory, its organic composition can and must be explained by natural processes. On the other side are those who argue that the evidence, taken as a whole, points to something more unsettling, something artificial. The debate is not just scientific, it is philosophical, it is emotional, it is about how much we are willing to believe and how far we dare to stretch our understanding of what the universe might contain. And it is in that tension between natural and artificial that Atlas becomes more than an object. It becomes a mirror of our own fear, our own hope, our own fragile place in the cosmos. The naturalists argue first with probability. They remind us that the galaxy is a violent place. Stars are born and die, planetary systems collapse, collisions hurl debris into interstellar space. Over billions of years, trillions upon trillions of objects must have been cast adrift, wandering aimlessly between the stars. Atlas, they say, is simply one of those wanderers. Its orbit may look precise, but in the infinite churn of cosmic motion, coincidences happen. Its dust may look suspicious, but every new class of object teaches us that the universe always has surprises. Its age, its organics, its scale, none of these require intelligence to explain. In this view, the real danger lies in letting our imaginations run too far ahead of the evidence. If we leap to aliens every time we face a puzzle, we risk abandoning science for sensationalism. That is the fear of the naturalists, that in our hunger for meaning, we will see design where none exists. And yet, the skeptics of the skeptics push back with equal force. They remind us that science has always advanced by entertaining the strange. Once people dismissed meteorites as superstition, until the rocks were collected and proven real. Once the idea of invisible waves carrying sound was fantasy, until radio became part of daily life. Once the notion of planets around other stars was speculation, until telescopes confirmed thousands of them. To dismiss the possibility of artificiality simply because it feels uncomfortable is as unscientific as blind belief. The anomalies of Atlas are not minor. They are not small quirks to be brushed aside. They are glaring, persistent contradictions that resist every attempt at natural explanation. To pretend otherwise is not caution, it is denial. The most striking argument for artificiality lies in the pattern itself. One interstellar anomaly could be dismissed. Two, within a decade, both showing strange behaviors, both appearing just as our instruments became capable of noticing this is harder to ignore. Oumuamua and Atlas together suggest a sequence, a rhythm, a story unfolding. In human history, patterns always reveal intent. Scouts precede surveys. Reconnaissance precedes presence. When the pieces fall into place, they stop looking random and start looking deliberate to those who see design. Atlas is not just another comet. It is a continuation of something that began in 2017, something that may not yet be finished. There is also the matter of timing. If Atlas were natural, its appearance now is nothing short of miraculous coincidence. For billions of years, it drifted unnoticed through the void, only to pass our system in the narrow window of history when humans had the tools to see it. It is as if the curtain lifted at the exact moment we were able to glimpse the stage. Naturalists call it chance. Believers in artificiality call it intent. Because if you wanted to reveal yourself to a civilization, wouldn't you wait until they were capable of noticing? Not too early, when the message would be missed. Not too late, when the message might cause panic. Precisely when the civilization was learning to look outward, when they were on the cusp of stepping beyond their cradle, that would be the perfect time. And that, uncannily, is exactly when Atlas arrived. For those defending the natural explanation, intent is a dangerous word. They argue that we should never invoke intelligence until every possible natural path is exhausted. They remind us of Occam's razor. The simplest explanation is usually the correct one. But Occam's razor does not mean the least imaginative explanation. It means the explanation that accounts for the evidence with the fewest assumptions. And sometimes, intelligence requires fewer assumptions than coincidence stacked upon putter's ink, which is simpler, that two interstellar anomalies appeared in sequence, timed perfectly with our observational capabilities, each displaying behaviors outside our models, by sheer accident, or that they were meant to be seen, that they were meant to puzzle us, that they were part of a plan. The answer depends on one's threshold for disbelief, on how far one is willing to stretch the fabric of chance before it snaps. The debate has become almost theological in its intensity. To some, insisting on natural explanations feels like clinging to a faith in randomness, a faith that the universe must be empty of intent, because the alternative is too overwhelming. To others, suggesting artificiality feels like grasping for meaning, a faith in the extraordinary because the ordinary feels inadequate. Both sides accuse the other of bias, and perhaps both are right. Humans are storytellers. We are uncomfortable with uncertainty. We want answers, and we will bend evidence to fit them. But Atlas resists bending. It sits in our sky too vast to ignore, too strange to explain, demanding we choose between the unthinkable and the unbelievable. What makes this debate even sharper is how it reflects back on us. If Atlas is natural, then we are alone in facing an indifferent universe, a cosmos filled with mysteries that we may never fully untangle. That is humbling, perhaps comforting, in its own way. But if Atlas is artificial, then we are not alone, and the implications are staggering. It means someone else is out there, someone older, wiser, perhaps watching, perhaps indifferent, perhaps curious. It means the universe is not empty. It means we are part of a larger story, one we did not write, one we are only just beginning to read. For many, that possibility is exhilarating. For others, it is terrifying. For all, it is transformative. The artificial theory also sparks questions that pierce deeper than science. If Atlas is designed, who built it? When? And why? A probe launched 10 billion years ago would imply a civilization that no longer exists. A ghost ship from a vanished people, carrying their legacy across the stars. A probe launched recently, on the other hand, would imply someone nearby, someone still active, someone close enough to have noticed us. Which is more unsettling, the ghost of a dead civilization or the gaze of a living one? And if it is a probe, is it benign, a surveyor cataloguing the galaxy? Or is it something more, a forerunner of intentions we cannot yet discern? Every answer births a dozen new questions, each more disquieting than the last. And yet, even amidst the debates, there is a quiet recognition that the truth may never be settled. Atlas will not stop and open itself for inspection. It will not broadcast a message we can decode. It will pass, just as Oumuamua passed, leaving us with only fragments of data, shadows of evidence, whispers of possibility. The naturalists will continue to build models, to find explanations, to insist that nature, not intelligence, holds the answer. The believers will continue to point to the anomalies, to the patterns, to the timing, insisting that design cannot be ruled out. And between them lies the rest of us, suspended in the tension, caught between fear and wonder, watching the sky and waiting for whatever comes next. In the end, the debate over natural or artificial may reveal less about Atlas than it does about ourselves. It shows how deeply we long for connection, how fiercely we cling to reason, how fragile our certainty becomes when faced with the unknown. Atlas does not care what we believe. It drifts on, vast and silent, carrying its secrets. But in its silence it has already spoken. It has forced us to confront the possibility that the universe is not what we thought it was. Whether natural or artificial, it has already changed us. Because now we know to look, now we know to question. Now we know that interstellar visitors are real, and that one day the answer to this debate will no longer be theoretical. One day the silence will break. One day we will know. The strangest possibility of all is that Oumuamua and Atlas were not silent after all. That their presence itself was a form of communication, a message written not in words but in mathematics, timing and trajectory. For centuries humans have dreamed of what first contact might look like. We imagine radio signals beamed across the stars, or glowing ships descending into our skies. But what if communication is subtler, quieter, more sophisticated? What if instead of shouting across the void, an advanced civilization speaks in whispers, objects slipping into our solar system that, if read correctly, carry meaning? This is the theory of cosmic communication, the idea that Oumuamua and Atlas are less about what they are, more about what they signify. Start with Oumuamua. Many noted that its strange acceleration could have been a form of signaling. A sudden change in speed, unexplained by gravity, is itself a kind of anomaly meant to be noticed. The fact that we debated it endlessly shows that it succeeded, even if no traditional message was encoded. The act of behaving unnaturally became the message. Pay attention. Some researchers even speculated that the tumbling of Oumuamua could have been deliberate, that its irregular spin might have been designed to reflect sunlight in ways that looked like coded flashes. Of course, to us, it looked chaotic, confusing. But imagine if hidden within those light curves was a pattern, a sequence, something intelligible, if only we had the right lens to decode it. If Oumuamua was indeed a scout, perhaps its communication was not verbal, but behavioral, a performance written in physics itself. Atlas then becomes the potential reply, or perhaps the second half of a sentence begun years earlier. Its very existence could be the continuation of the message. One small, fast object in 2017-17, followed by a vast, deliberate one in 2025. To us, it looks like coincidence, but to whoever sent them, the sequence may be the communication. The scout says, "We see you." The follow-up says, "We are here." In this way, the conversation is not carried in radio waves, but in the choreography of celestial arrivals. Each visitor becomes a word, each orbit a sentence, each trajectory a paragraph in a story too large for us to yet grasp. This raises the unsettling thought that we may already be participating in a dialogue without even realizing it. Imagine if humanity were the subject of a test, and the test was simple: notice us. Oumuamua was the question: are you watching? Our telescopes caught it, our scientists debated it, our media sensationalized it. In doing so, we answered, yes, we are. Atlas then becomes the response, the second probe, the escalation that says, good, then you are ready for the next step. The very act of detecting them could be the signal they were waiting for. Communication doesn't always mean transmitting information. Sometimes it means establishing awareness, proving readiness. And perhaps that's all Oumuamua and Atlas were designed to do: confirm that we have reached the stage where communication is possible. Of course, others push the theory further, suggesting that communication may have been literal, that Oumuamua or Atlas could have been emitting signals we failed to detect. Narrow beam transmissions, for example, aimed away from Earth, invisible to our instruments, or signals encoded in wavelength we don't yet monitor, hidden in parts of the spectrum we rarely explore. It is possible, they argue, that Oumuamua was talking the entire time, broadcasting back to its origin, and we simply didn't know how to listen. If so, then Atlas could be continuing the dialogue, relaying observations, sending back information about our system, about Earth, about us. To us, it looks like silence. To them, it could be a torrent of conversation, already underway. Another possibility is that the communication wasn't directed outward at all, but inward toward us. That Oumuamua and Atlas were designed not to phone home, but to provoke us into thought, to force us to ask the questions we are asking now. After all, what better way to communicate with a young civilization than to challenge its assumptions, to present it with anomalies it cannot easily dismiss? Oumuamua shattered our belief that interstellar visitors were beyond our reach. Atlas shattered our belief that they would behave predictably. Together, they compel us to consider the unthinkable, that we are not alone, that realization in itself could be the message. No words, no signals, just presence. A presence that forces recognition. In this light, Oumuamua and Atlas are less like probes and more like riddles, puzzles left in our path to expand our awareness. Skeptics argue, as always, that this stretches the data too far. They say communication requires intent, and intent cannot be proven from anomalies alone. A rock, no matter how strange, does not speak. But intent is not always about proof. It is about interpretation. When we see footprints in the sand, we infer the presence of a walker. When we see a carved stone, we infer the hand of a sculptor. Atlas and Oumuamua are the cosmic footprints, the carved stones in the desert of space. To say they are meaningless is to close our eyes to the possibility that meaning exists. To say they are a message is to acknowledge that sometimes communication is not about language, but about being noticed. There is also the tantalizing thought that the message is incomplete, that Oumuamua and Atlas are only the first syllables of a longer word. Communication, after all, rarely consists of one phrase. It is built from sequences, repetitions, escalating complexity. If these objects are messages, then perhaps more are coming, each one building upon the last, each one adding clarity to the conversation. Perhaps Atlas is not the conclusion, but the continuation, a comma rather than a period. If so, then the real communication may still lie ahead, waiting in the arrivals yet to come. But what would such a conversation mean for us? If the message is "you are not alone," then humanity must grapple with the implications. Religions, philosophies, sciences, all would be shaken. If the message is "we are watching," then we must confront the reality of surveillance, of being observed without consent. If the message is "we are coming," then we must face the possibility of an encounter we cannot control. And if the message is something subtler, something beyond our comprehension, then we must accept that we are not yet ready to understand. Each possibility reshapes our sense of place, our sense of safety, our sense of destiny. Communication with another intelligence, even in the faintest form, is not just about data, it is about identity. It forces us to redefine who we are in the context of something greater. And yet perhaps the cruelest twist of all is that we may never know. If the communication is encoded in ways we cannot detect, if the message is hidden in the spin of a rock or the glow of dust, then we may be forever deaf to it. The objects will pass, the debates will rage, but the truth will remain elusive. In that sense, Oumuamua and Atlas may be the ultimate form of communication, a message that says not only we are here, but also you are not ready. The silence becomes part of the dialogue. The absence of clarity becomes the lesson. Sometimes to be left in uncertainty is itself a form of communication, a way of forcing growth. So here we stand, caught between silence and speculation, watching as the objects drift away, wondering if they were trying to speak. Perhaps they were, perhaps they weren't. Perhaps the message is not in the objects themselves, but in our reaction to them. Because in the end, the greatest proof of communication may not be in what they sent, but in how we responded. We noticed, we debated, we imagined, and maybe, just maybe, that was the entire point. The question that lingers above all others, the one that haunts scientists, dreamers and skeptics alike, is deceptively simple. Why now? For billions of years, our solar system spun undisturbed, its planets circling in quiet repetition, its comets and asteroids following familiar rhythms. For billions of years, Earth itself evolved in isolation, its civilizations rising and falling without once recording a visitor from beyond. And then within the space of a single human lifetime, just a handful of years, two extraordinary interstellar objects appear. Oumuamua in 2017, Atlas in 2025. Two intruders from the depths of interstellar space, two anomalies so strange they spark debates that still rage unanswered. Why would such events unfold now in this precise moment of human history, after aeons of silence? Is it coincidence? Or is it intention? The simplest answer, of course, is coincidence. The galaxy is vast, and objects like Oumuamua and Atlas must exist in staggering numbers, flung loose from their parent systems by gravitational chaos and drifting endlessly through the void. That two of them would pass near Earth within the span of a decade might simply reflect our growing ability to detect them. Our telescopes are sharper, our surveys more sensitive, our eyes finely tuned to notice what may have been happening all along. Perhaps interstellar visitors have come before, thousands of times, slipping past our blind eyes without fanfare. If that is the case, then the timing says more about us than about them. We are only now capable of seeing what was always there. In this view, the universe did not change. Our perception did. But the coincidence explanation falters when we examine the specifics. Oumuamua was not just any rock. It was bizarre in shape, speed, and behavior. Atlas was not just any comet. It was colossal, ancient, and cloaked in dust that defied expectation. To suggest that two such anomalies appeared so close together, so soon after humanity developed the ability to detect them, feels like stretching chance to the breaking point. Coincidences do occur, but the universe is not in the habit of staging them in such dramatic fashion. And that leads us back to the darker, more thrilling possibility that the timing is not accidental, that there is meaning in the sequence, that why now is the very heart of the mystery. If the arrivals were deliberate, then the first explanation is the most obvious. They came because we are ready. For millennia, humanity lacked the tools to notice such visitors. Our ancestors gazed at the stars, but they had no telescopes, no spectrometers, no surveys mapping the sky in real time. An object like Oumuamua could have passed 1,000 years ago, and no one would have seen it. But now, in the 21st century, we have reached a threshold. We scan the heavens daily, mapping every object, cataloguing every anomaly. We have the ability to track, to measure, to debate. Perhaps the visitors waited for this moment, knowing their presence would go undetected until our awareness was advanced enough. Perhaps the timing is the message. You have reached the point where you can see us. Therefore we appear. Another possibility is more unsettling, that they came not because we are ready, but because we are dangerous. In the last century alone, humanity has split the atom, reached space, and begun broadcasting our presence into the cosmos. Our signals race outward at the speed of light, announcing to anyone listening that a technological civilization now occupies Earth. Perhaps Oumuamua and Atlas are not greetings, but inspections, the cosmic equivalent of a neighbor glancing over the fence when they hear shouting next door. Someone new has awakened. The message might be, go see what they are becoming. If so, then the timing is not a gift, but a warning. We have drawn attention to ourselves, and now the watchers are here. There is also the possibility that why now has nothing to do with us at all, that Oumuamua and Atlas are part of a much larger cycle, a rhythm of exploration or dispersal that has been unfolding across the galaxy for millions of years. Imagine a civilization that launches probes at regular intervals, each one designed to drift between stars, seeding information or gathering data. The fact that two such objects reached us within a decade might simply reflect the natural beat of that cycle, and we happen to be in the path at this moment in time. To them, it may not be about now. To them, we may not even matter. But to us, caught at the intersection of their trajectory and our awareness, the timing feels like destiny. And yet there is another layer still, one that unsettles even further. What if the arrivals are not coincidences, not cycles, not inspections, but responses? Consider the possibility that something we did triggered their appearance. Our radio transmissions have been traveling into space for over a century. Our first atomic tests released bursts of radiation into the cosmos. Our spacecraft have left the cradle of Earth and pierced interplanetary space. Perhaps these were signals, intentional or not, that drew attention. Perhaps Oumuamua was dispatched in response to our earliest broadcasts. Perhaps Atlas is the reply to our growing expansion into the solar system. If so, then why now is not an accident. It is cause and effect. We spoke, they answered. Of course, skeptics push back against all of these ideas. They argue that the allure of timing is a human trap, a trick of pattern recognition. We are creatures obsessed with meaning. We search for purpose in chaos, stories in randomness, significance in chance. If a comet appeared today, we would tie it to current events. If it appeared tomorrow, we would tie it to tomorrow's. The universe, they say, is not about us. It is not a stage play performed for humanity's benefit. Oumuamua and Atlas do not arrive now for any reason. They simply arrive. To read intention into their timing is to project our own hunger for significance onto indifferent stones. But this dismissal feels hollow when confronted with the depth of the anomalies. For even if the universe is indifferent, we cannot ignore how perfectly these visitors align with the thresholds of our development. They appeared just as we learned to look outward, just as we became a spacefaring species, just as our civilization tipped from the local to the cosmic. Even if this is coincidence, it is a coincidence so profound it borders on design, and for many that is enough to wonder if why now is the key to everything. Ultimately, the question of timing forces us to confront our own place in history. We are not the first humans to look at the stars, but we are the first to witness objects crossing between them. We are not the first to imagine contact, but we are the first to face anomalies that make contact seem plausible. Whether by chance or intention, we are living in the moment when the silence of the cosmos has been broken, not by a signal but by presence, and that means history has shifted. Humanity is no longer a species confined to Earth, imagining the universe in isolation. Humanity is now a species confronted with the possibility that the universe notices us back. So why now? Because we are ready, because we are loud, because we are expanding, because cycles converge, because coincidences happen, because meaning demands to be found. Perhaps all of these answers are true, perhaps none are. But what matters most is that we are asking the question. We are alive at the moment when the stars themselves seem to whisper, when interstellar visitors force us to reconsider everything we thought we knew. For billions of years, no one asked why now, because nothing like this had ever happened. Today we ask it, because it has. And whether the answer lies in chance, in design, or in something stranger still, one truth is undeniable. The timing has changed us. It has made us aware, cautious, curious. It has made us look up with new eyes. And perhaps that, more than anything else, was the point all along. If the arrival of Oumuamua and Atlas has taught us anything, it is that we must begin to think not just about what has happened, but about what comes next. The future no longer feels like an abstract horizon where questions about other civilizations can be filed away for distant generations. It feels immediate, pressing, and alive. The sight of one interstellar visitor might have been an academic curiosity. The sight of two, within years of one another, has forced us into a different frame. Expectation. What else may be coming? What other anomalies are already on their way, invisible against the dark until they sweep past our star? The debate is no longer whether the story has begun. The debate is what the next chapter will hold, and whether we will be prepared when it arrives. The first expectation is simple. There will be more. The galaxy is too full, too restless, for Oumuamua and Atlas to be the last wanderers we see. Already, surveys like the Vera Rubin Observatory's upcoming Sky Mapper are poised to scan the heavens with unprecedented sensitivity. Astronomers anticipate detecting dozens, perhaps hundreds of interstellar objects within the next few decades. But the question is not just quantity, it is character. Will these future arrivals behave like ordinary debris, obeying the rules of comets and asteroids, or will they, like Oumuamua and Atlas, defy explanation, taunting us with anomalies that hint at design? The answer will determine whether the mystery deepens or dissolves. If the next visitors look ordinary, perhaps the story ends with curiosity. If they look extraordinary, then we must brace for a future in which the extraordinary becomes the new normal. Another expectation lies in technology. As each new visitor arrives, our ability to study them will sharpen. When Oumuamua appeared, we were caught off guard. We had no spacecraft ready to chase it, no probes to intercept. With Atlas, we again lacked the means to approach, but the lesson has been learned. Projects are already underway to design missions capable of rapid launch, to send craft after the next interstellar visitor at a moment's notice. Imagine a probe closing in on one of these objects, snapping images, analyzing dust, probing magnetic fields. The day will come when the data we debate in fragments will be replaced by direct, undeniable evidence. And in that day, we will no longer argue about what these objects are. We will know. That expectation burns at the center of the scientific community, the hope that the next anomaly will not escape us. But outside the laboratories and observatories, a different kind of expectation grows, one steeped in culture, in myth, in human imagination. People expect revelation. They expect that if these objects are scouts or messengers, then their presence means more is coming. The shape of that more varies depending on perspective. Some imagine peaceful contact, the unveiling of knowledge from civilizations older and wiser than ours. Others imagine caution, surveillance, perhaps a cold curiosity with no intention of contact. And still others imagine danger, that the scouts herald fleets, that the surveyors prepare the way for presence that will not ask permission. In every scenario, the expectation is the same: change. That humanity will not remain what it is today, that these visitors mark the threshold of a new age, one defined by awareness that we are no longer alone in the dark. In this way, expectation itself becomes a force. When people expect the extraordinary, they begin to act differently. Scientists push harder for funding, for missions, for instruments that might catch the next anomaly. Philosophers craft new frameworks for what humanity's role in the universe might be. Governments quietly debate strategies for what to do if undeniable evidence of intelligence arrives. Even religion strains under the weight of possibility, adjusting its narratives to imagine what contact would mean for creation stories, for divinity, for purpose. The objects may pass, silent and indifferent, but the expectations they leave behind are louder than any signal. They change us before they even reveal themselves fully. There is also the expectation of escalation. History teaches us that first arrivals are rarely the last. Scouts precede surveys. Small probes precede larger ones. Signals precede encounters. If Oumuamua was the scout and Atlas the surveyor, then the pattern suggests that something greater lies ahead. That expectation is difficult to silence once it takes root. Each time a new comet is detected, people will wonder, is this another anomaly? Each time a new trajectory is calculated, someone will ask, does it fit the pattern? Suspicion becomes habit, and habit becomes vigilance. Humanity is now watching the skies with different eyes, not just looking for rocks but for signs. The expectation is no longer passive. It is hungry, restless, waiting for the curtain to rise again. Of course, not all expectations are hopeful. There is the expectation of disappointment, that the anomalies may, after all, prove to be natural quirks, their mysteries solved with better instruments and sharper data, that we will invest dreams of contact only to discover the universe is indifferent, filled with rocks and ice and dust, but no voices. This expectation is heavy, a kind of cosmic letdown waiting to happen. And yet even this does not undo the shift that has already occurred, because whether natural or artificial, ordinary or extraordinary, Oumuamua and Atlas proved that interstellar visitors are real. That alone is enough to keep our eyes upward, our minds racing, our future reoriented around the stars. Even in disappointment, expectation fuels discovery. Then there is the strangest expectation of all, that the visitors may not just appear, but engage, that they may not simply drift past, but choose to act, to signal, to reveal. What would that look like? A sudden change in trajectory? A burst of radiation aimed deliberately at Earth? A maneuver too precise to dismiss as natural? Any one of these would be the spark that ends debate forever. Many expect, or at least secretly hope, that such a moment lies ahead. They watch not just for anomalies but for intent, and if it comes, even in the smallest gesture, it will redefine history in an instant. The expectation of contact is a quiet current that runs beneath every conversation about these objects, even when unspoken. But perhaps the most profound expectation is not about them at all. It is about us. The future will test humanity, not only with what arrives, but with how we respond. Will we meet the unknown with fear or with curiosity? Will we fracture into paranoia and division, or unite under the shared recognition that we are part of a larger story? These are the expectations we must wrestle with now, before the next anomaly arrives. Because whether the visitors are natural or artificial, harmless or purposeful, the one thing they guarantee is change, and how we meet that change will decide not just the story of the visitors, but the story of us. So when people ask, what comes next? The answer is not just about the stars, it is about Earth. The expectation is not only that we will see more, but that we must become more. We're aware, more prepared, more willing to embrace uncertainty. The next visitor may arrive tomorrow, or in 100 years. It may be ordinary, or it may shatter every model we hold, but the expectation has already taken root, and it will not let go. Humanity now lives in the age of interstellar arrivals, an age where the sky itself feels like it is watching us back. That is the future, uncertain and unstoppable. And in that uncertainty lies the greatest expectation of all, that when the next chapter unfolds, we will not simply observe it, we will be part of it. Long before telescopes and data charts, long before we could measure light curves or calculate trajectories, humanity told stories about the sky. We looked at comets and saw omens of kings rising and kingdoms falling. We mapped constellations and imagined gods, beasts, and heroes written in the heavens. Every culture, in every age, turned the cosmos into a mirror of itself. And now, with Oumuamua and Atlas, we find ourselves doing the same thing once again. Except this time, the mirror reflects not only myth but science, not only imagination but unsettling possibility. The cultural impact of these visitors has already rippled far beyond observatories and academic journals. It has seeped into art, religion, politics, and the collective imagination of a world that suddenly finds itself questioning what it means to be human under a sky that may not be empty after all. The first shock came with Oumuamua. Its name itself, Hawaiian for scout or messenger from afar, framed the way the public received it. Scientists may have intended the name as a neutral nod to discovery, but words have power, and the word messenger resonated far beyond technical circles. News outlets leapt on the idea, social media flooded with speculation. Overnight, Oumuamua transformed from a faint streak in a telescope into a symbol, a mysterious emissary that seemed to embody humanity's oldest dream and deepest fear, that we are not alone. For some, this sparked wonder, for others, dread, but for all, it was impossible to ignore. The culture of Earth had changed, even if only in whispers. Atlas, when it appeared, amplified that change. Its size, its strange behavior, its haunting dust trail, all of it fed directly into the narrative Oumuamua had begun. If the first was a scout, many whispered, then this must be the surveyor. If the first was a messenger, then this must be the continuation of the message. The fact that both objects arrived within such a short span of time gave them a symbolic rhythm, a story arc the public latched onto with an almost mythic hunger. It was no longer just astronomers debating orbital anomalies. It was artists painting visions of interstellar probes. It was writers spinning tales of ancient civilizations. It was filmmakers weaving these mysteries into cinema. The cultural impact was not confined to data. It was spreading through imagination, shaping how billions of people envisioned the universe and their place within it. Religion, too, felt the tremors. For centuries, questions of cosmic neighbors have tested theology. Are we unique creations alone under divine care? Or are we part of a larger tapestry, one in which life is abundant and civilizations countless. Oumuamua and Atlas did not answer these questions, but they forced them to the surface. In pulpits and sermons, priests and preachers grappled with the implications. Some saw the objects as affirmations of faith, signs that creation was vaster and more wondrous than Scripture had yet revealed. Others saw them as threats to dogma, challenges to doctrines that insisted on humanity's centrality. Either way, belief was stirred, reshaped, stretched. In this sense, the cultural impact of these visitors was not only about science, it was about the most intimate frameworks of meaning that guide human life. The political world was not immune either. Governments, though often silent publicly, could not ignore the public's fascination. Behind closed doors, committees convened to ask uncomfortable questions. What if the anomalies were not natural? What if they represented surveillance or worse, intention? Should humanity prepare? Should we attempt to communicate? These questions rarely made headlines, but their shadows appeared in policy proposals, in new funding for space defense programs, in subtle shifts in how nations described their role in space exploration. Atlas, in particular, with its immense size and strange emissions, became a spectre that hovered in the background of geopolitical strategy. Cultural impact does not stop at imagination. It shapes budgets, alliances, and priorities. Perhaps the most profound cultural shift, however, occurred at the level of collective psychology. Humanity has long lived with a paradox. We crave contact, but fear it. We dream of being noticed, yet we tremble at the thought of what noticing might bring. Oumuamua and Atlas dragged that paradox into daylight. Suddenly, people everywhere were asking questions that had once been confined to philosophy classrooms or late-night conversations under the stars. If we are not alone, what does that mean for our identity as a species? If others are out there, do they see us as equals, as curiosities, or as prey? These questions entered popular culture in ways both playful and serious. Memes joked about alien scouts. Novels speculated about ancient watch. Documentaries explored the science with tones that oscillated between awe and dread. The visitors became symbols of the unknown itself, reminders that the universe may be far stranger than we dare to admit. What makes the cultural impact even deeper is its persistence. Unlike fleeting news stories, the mystery of Oumuamua and Atlas cannot be resolved easily. Their anomalies linger, resisting tidy explanations, and in that resistance they remain alive in the cultural mind. Every new comet discovered is compared to them. Every unexplained signal from the cosmos is framed in their shadow. They have become reference points, cultural shorthand for mystery, for possibility, for the thin line between science and speculation. Once comets were omens, now interstellar objects are. The stage may have changed, but the role they play in the human psyche has not. They are our modern portents, not of kings and plagues, but of cosmic neighbors and galactic stories. Artistic expression has embraced this with fervor. Painters render Oumuamua as a silent shard of alien metal, gliding like a spear through darkness. Musicians compose symphonies inspired by Atlas, blending the vastness of space with the unease of the unknown. Writers build mythologies around the arrivals, turning them into characters in humanity's ongoing drama with the stars. Even science fiction, long the domain of speculation, now draws directly from real data, blurring the line between imagination and reality. Oumuamua and Atlas have joined the cultural canon alongside UFOs, Martian canals, and radio signals from the void. But unlike those older myths, these are real, measurable, undeniable. They are no longer fiction. They are fact refracted through imagination. And yet, perhaps the deepest cultural impact lies in humility. For centuries, humanity has told itself that we are masters of our world, that our stories matter above all, that our stories matter above all. But Oumuamua and Atlas remind us of scale. They remind us that the universe is vast, that our solar system is a single grain of sand in an ocean without shore. They remind us that visitors can appear unannounced, indifferent to our calendars, our governments, our fears. This realization is unsettling, but it is also liberating. It pushes culture toward a broader horizon, forcing us to see ourselves not just as citizens of Earth, but as participants in a cosmic stage. That shift in identity may be the most profound cultural impact of all. In the end, the story of Oumuamua and Atlas is not only about science, not only about what they are or where they came from. It is about us, how we react, how we imagine, how we weave mystery into meaning. They are cosmic objects, yes, but they are also cultural catalysts, stirring ancient instincts and modern debates alike. Their legacy will not be confined to data archives. It will live in the myths we tell, the art we create, the policies we craft, the ways we dream. The sky has always been our canvas. Oumuamua and Atlas have given us new colors, and we are painting with them already. Science prides itself on order, on models that predict, equations that explain, categories that classify. For centuries, this framework has expanded outward, from Earth to the stars, building a sense that the universe, however vast, obeys rules we can grasp. But then came Oumuamua, and then Atlas, and suddenly those rules faltered. An object elongated beyond reason, tumbling strangely, accelerating without gas. A second object, colossal in size, cloaked in dust, without the expected vapor, composed of ancient materials that defy the neat boxes of comets and asteroids. Together they have forced scientists to confront a reality they rarely acknowledge. Sometimes the data refuses to fit. Sometimes the anomalies pile high enough that the framework bends under their weight. And in that bending lies the possibility of a paradigm shift, a transformation in how we understand not just interstellar visitors but the nature of science itself. At first the instinct was defense. The scientific community rushed to explain Oumuamua within existing models, even if those models strained against the facts. Perhaps it was a fragment of a larger body, chipped off by a cosmic collision. Perhaps it was a hydrogen iceberg, sublimating invisibly. Perhaps it was nitrogen ice, or a pancake-shaped shard, or some other exotic natural relic. Each hypothesis was ingenious, yet each ran into contradictions. Hydrogen ice would not survive the journey. Nitrogen ice lacked supporting evidence. Collisional fragments could not easily explain the acceleration. In every case, the data seemed to mock the explanations. And yet, the idea of considering artificiality, the notion that Oumuamua might be a probe, was treated as taboo, as though even entertaining the thought was unscientific. The paradigm at the time was clear. All explanations must be natural, no matter how tortured. Anything else was fantasy. Atlas repeated the cycle. Scientists initially labeled it a comet, then scrambled when its dust betrayed the absence of gas. Again, hypotheses bloomed. Perhaps its composition was unique. Perhaps its surface chemistry produced invisible volatiles. Perhaps cracks or mechanical stress explained the shedding. Once again, each explanation solved part of the puzzle, but not the whole. The anomalies lingered, unresolved, like splinters in the skin of scientific certainty. And yet again, the possibility of artificiality was met with resistance, not because the data ruled it out, but because the paradigm did. To admit the possibility meant rewriting the foundations, and revolutions in science rarely begin with open arms. They begin with denial. But denial cannot last forever. Already, cracks in the paradigm are visible. Some researchers, though cautious, now admit that the artificial hypothesis cannot be dismissed outright. Prestigious journals, once closed to such speculation, have begun to publish serious discussions of it. Conferences once focused solely on natural explanations now include sessions that allow whispers of intent, whispers of design. The shift is not complete, but it has begun, and it mirrors the great paradigm shifts of history. Think of the heliocentric model, when Copernicus dared suggest Earth was not the center of the universe. For centuries, the geocentric model had seemed unassailable, supported by observation and belief alike. But anomalies, retrograde motion, the complexities of epicycles piled higher until the old system could no longer stand. Or consider plate tectonics, once ridiculed as nonsense until the evidence of drifting continents and seafloor spreading forced acceptance. Paradigm shifts always follow the same arc: denial, resistance, debate, and finally, acceptance. Oumuamua and Atlas may be the beginning of such an arc, not just for astronomy, but for humanity's understanding of its place in the cosmos. The core of the paradigm shift is this: the universe may not be silent. For decades, the prevailing assumption has been that if extraterrestrial intelligence exists, it is distant, hidden, and undetectable. The Fermi paradox haunted us. If life is common, where is everyone? Oumuamua and Atlas crack that paradox open. They suggest that everyone might already be passing through, not with flashy signals or fleets of ships, but with subtle visitors disguised as rocks and comets. If true, this means our framework for SETI searching for radio signals, scanning for deliberate broadcasts, may have been too narrow all along. Intelligence might not communicate with us in ways we expect. It might not communicate at all. It might simply reveal itself through presence, through anomalies that cannot be explained away. That realization alone is a paradigm shift waiting to happen. Another shift lies in how we view interstellar objects themselves. Before Oumuamua, few believed we would ever detect such wanderers with regularity. The assumption was that they were rare, fleeting, almost beyond reach. Oumuamua shattered that assumption. Atlas drove the point home. Now scientists accept that interstellar visitors are not rare. They are constant, a steady rain of relics and anomalies passing through our system unnoticed. Until recently, this reframes the solar system itself, not as an isolated bubble, but as a crossroads in a galaxy filled with travelers. To study the solar system now means to study the galaxy. That conceptual leap reshapes astronomy, geology, and even planetary defense. The paradigm has already shifted. We no longer live in an isolated system. We live on a cosmic highway. Yet the most profound paradigm shift may not be scientific at all, but psychological. Science teaches us to be cautious, to demand evidence, to resist extraordinary claims until extraordinary proof is offered. That discipline is vital, but it can also become a cage. When anomalies like Oumuamua and Atlas arrive, the reflex to force them into existing categories can blind us to the possibility that the categories themselves are flawed. The paradigm shift, then, is less about admitting aliens and more about admitting ignorance, about saying openly, we do not know, and perhaps the rules we rely on must be rewritten. That humility is the seed of revolution, and revolutions in thought always begin when we admit that our certainty has limits. If the shift takes hold, its consequences will ripple far beyond science. It will change education, shaping how future generations learn about the universe, not as a closed book, but as an unfolding story where the unknown is as important as the known. It will change philosophy, forcing us to rethink our assumptions about life, intelligence, and meaning. It will change policy, demanding that governments prepare for a universe that may include neighbors, whether curious or indifferent. And it will change culture, embedding the idea that humanity is not the measure of all things, but one participant in a drama older and larger than itself. Paradigm shifts do not stay in the laboratory. They spread through civilization. Of course, the transition will not be smooth. Many will cling to the old framework, insisting that Oumuamua and Atlas must have natural explanations, no matter how convoluted. Others will leap too far, embracing fantasies unsupported by evidence. The true paradigm shift lies in the balance between skepticism and imagination, between data and possibility. It will require courage to resist the comfort of certainty, to accept the weight of the unknown, to stand in the tension between natural and artificial, without rushing to either extreme. That tension is uncomfortable, but it is also fertile. It is the place where new understanding grows. Perhaps, decades from now, when future anomalies have been studied, when missions have intercepted interstellar objects, when the debate has played out in full, historians will look back at this moment as the dawn of a new era. They will say, Oumuamua was the spark, Atlas was the fire, and from those anomalies came a transformation in how humanity saw the universe and itself. That is the true paradigm shift, not just scientific, but civilizational. A shift from asking what are they, to asking what are we, in light of them. And in that question, everything changes. Every story has an end game, whether intended or accidental, and when we look at Oumuamua and Atlas, the haunting question is not simply what they are, but where this all might lead. What are the possible conclusions of this unfolding drama? Are these visitors just strange wanderers that will leave us with curiosity but no consequence? Or are they the first movements in a larger symphony, one that could shape the destiny of humanity itself? To ask about the endgame is to confront the full spectrum of possibility, from the mundane to the transcendent, from the reassuring to the terrifying, and perhaps in that spectrum we catch a glimpse of how fragile and unprepared we truly are. The most conservative endgame is also the simplest: nothing. In this view, Oumuamua and Atlas are natural anomalies, fascinating but unremarkable in the broader scheme of the galaxy. They pass, we study them, we adjust our models, and life on Earth continues as it always has. In this ending, the mystery dissolves into knowledge, the unknown becomes routine, and the excitement fades into history. Scientists will rewrite textbooks to include new categories of interstellar objects. Historians will record the debates, and future generations will marvel that we once thought they might be more. For some, this endgame is comforting. It means the universe remains indifferent, free of watchers, free of intentions that might unsettle us. For others, it is disappointing, a return to silence after a moment of wonder. But whether comforting or disappointing, it is the least disruptive outcome, and perhaps the one most aligned with the stubborn conservatism of science. The second possible endgame is subtler: surveillance. Imagine that Oumuamua and Atlas were probes, whether ancient or modern, designed not to announce themselves but to observe. They may have already completed their mission, gathering data on Earth and humanity, transmitting it silently back to their origin. If this is the endgame, then we are already under observation, already catalogued in someone else's ledger of civilization. In this scenario, there is no invasion, no revelation, only awareness that we are known. The endgame here is unsettling, not because it brings change, but because it brings none. We continue as we are, but under the shadow of being what? Like animals in a preserve, unaware of the biologists in the brush. We may never know what conclusions are being drawn about us, or whether those conclusions will shape our future. A third possibility is communication. In this endgame, Oumuamua was the opening gesture, Atlas the continuation, and a third act lies ahead, an unmistakable signal, a deliberate maneuver, or a message encoded in physics itself. Perhaps the objects will behave in ways so undeniable that even the most cautious scientist must admit intelligence. Or perhaps the communication will be indirect, designed to provoke us into reaching out first. In this ending, humanity faces its first true dialogue with another intelligence, and the consequences are incalculable. Will we understand the message? Will we even recognize it as language? And if we do, will the exchange be comforting, terrifying, or incomprehensible? This endgame is the one most often dreamed of in science fiction, but it is also the one that forces us to confront our deepest unpreparedness. We are not ready to speak for a planet. We are not ready to decide what words should carry the weight of humanity. And yet, if communication is the endgame, readiness may not matter. The conversation will come whether we are ready or not. The fourth possible endgame is intervention. In this outcome, Oumuamua and Atlas are not just probes, not just messengers, but precursors. They survey, they test, they prepare the way for something larger, perhaps fleets, perhaps structures, perhaps presences beyond our comprehension. Intervention does not necessarily mean conquest. It could mean guidance, the arrival of entities that shape our development, offering knowledge or warnings, or it could mean interference, a more forceful insertion into our story, treating humanity not as partners, but as subjects. In either case, the endgame is radical transformation. Civilization would no longer be defined by its own trajectory, but by interaction with forces far beyond its control. For some, this is salvation, the arrival of wisdom to save us from ourselves. For others, it is doom, the end of autonomy, the loss of destiny. Intervention in any form would mark the beginning of a new chapter in history, one written by hands not our own. And then, there is the darkest possible endgame, termination. It is not inconceivable that Oumuamua and Atlas could be harbingers of danger. A civilization advanced enough to send interstellar probes may also be advanced enough to see other civilizations as threats. From this perspective, the visitors could be scouts not for communication or guidance, but for judgment. They observe, they assess, and they report. And the report may not favor us. Perhaps we are deemed too violent, too unstable, too destructive to be allowed to expand. If so, the endgame could be elimination, quiet or sudden, carried out by forces beyond our comprehension. This possibility is the most chilling because it strips away the comforting illusion of cosmic benevolence. It confronts us with the reality that intelligence does not always imply kindness, and that survival may not be guaranteed simply because we crave it. Of course, there is another endgame that is stranger still: irrelevance. In this outcome, Oumuamua and Atlas were never about us at all. They were part of some larger mission, some vast project that has nothing to do with Earth. Their paths through our solar system were incidental. They're anomalies, products of goals that we cannot even conceive. In this ending, we are not chosen, not targeted, not even noticed. We are simply bystanders, caught in the wake of something vaster than ourselves. For many, this endgame is the most humbling of all. It suggests that we are not participants in a cosmic story, but extras on a stage where the real drama unfolds elsewhere. And yet even irrelevance carries weight, because it forces us to confront the limits of our significance. Across all these possibilities, one truth emerges: the end game is not theirs alone, it is ours. How we interpret Oumuamua and Atlas, how we respond to the anomalies, how we prepare for what may come next, all of these shape the story as much as the objects themselves. If we dismiss them as natural, the end game is a quiet one. If we treat them as signals, the end game is dialogue. If we fear them, the end game may be paranoia. If we embrace them, the end game may be transformation. The visitors themselves may be silent, but we are already writing endings in our minds, endings that reveal more about us than about them. And perhaps that is the most profound end game of all: reflection. Whether natural or artificial, benign or threatening, Oumuamua and Atlas force us to confront who we are, where we are, and what we hope for in the cosmos. They compel us to imagine futures that range from silence to apocalypse, from wonder to despair. In doing so, they shape culture, science, and philosophy in ways no other astronomical discovery has in living memory. They may pass into darkness, leaving no further trace, but the end game they have already set in motion will not fade. It is written in us now, in our expectations, our fears, our dreams. The story may be cosmic, but the end game is human. In the end, the mystery of Oumuamua and Atlas may never yield a single clean answer. They came from the dark, glided silently through our solar system, and slipped away, leaving behind not certainty but questions. Yet perhaps that is their true legacy, not what they were, but what they awakened in us. For a brief moment, humanity was united in wonder, in speculation, in the shared recognition that we are not as alone or as secure as we once believed. Two interstellar visitors, separated by only a few years, reminded us that the universe is not static, not silent, but dynamic and alive. They forced us to look outward with fresh eyes, to question old assumptions, and to confront possibilities that stretch beyond the boundaries of our imagination. If they were natural, then they expand our knowledge of cosmic mechanics, reshaping how we understand the formation and behavior of objects that wander between stars. If they were artificial, then they are the greatest discovery in human history, evidence of intelligence beyond Earth, proof that we are participants in a larger cosmic drama. And if we cannot yet decide between those two, the uncertainty itself is valuable. It keeps us restless, curious, unwilling to settle into complacency. The silence of the sky is not as quiet as it seemed, and in that subtle noise we find new purpose. Their legacy is also cultural. Oumuamua and Atlas entered not just the journals of astronomers, but the stories of poets, the canvases of artists, the pulpits of preachers, and the conversations of ordinary people. They became symbols, messengers, scouts, omens, reminders. They wove themselves into our myths as naturally as any comet or eclipse ever did. That alone ensures that centuries from now, when the data has faded into archives, the stories will remain. People will still speak of the first visitors, of the time humanity glimpsed something inexplicable and dared to wonder if it was more. In this way, the objects are no longer just themselves. They are catalysts, shaping us as much as we try to decipher them. And then there is the scientific legacy. Already, missions are being designed to intercept the next interstellar visitor. Already, telescopes are preparing to scan the heavens with greater precision. Already, researchers are speaking with more openness about possibilities once dismissed as fantasy. The paradigm has shifted. We no longer imagine the solar system as a closed bubble, but as a crossroad where travelers may pass. That shift will guide exploration, funding, and discovery for generations. Whether or not the visitors were intelligent, they have made us more intelligent in how we approach the cosmos. They have expanded the boundaries of what science dares to ask. But perhaps the deepest legacy is existential. Oumuamua and Atlas forced us to confront our place in the universe. They asked, silently but insistently, who we are in relation to the cosmos. Are we alone, struggling in isolation, or are we part of something larger, a story that began long before Earth existed and will continue long after it is gone. That question may not have an answer yet, but it reshapes us simply by being asked. It humbles us, excites us, and frightens us all at once. And it may be the most important question humanity has ever faced. So the conclusion is this: the story of Oumuamua and Atlas is unfinished. It is not contained in their brief passages through our skies, nor in the debates about their nature. It lives in what comes after, in how we respond, how we imagine, how we prepare for the next visitor, and the next, and the next. Their legacy is not certainty, but possibility, and in that possibility lies the future. Whether they were rocks or probes, relics or messengers, the truth is that they have already changed us. They reminded us that the universe is vast, unpredictable, and filled with wonder. They reminded us to look up, to ask questions, to be ready for whatever comes. And perhaps that is their greatest gift, not answers, but the courage to keep seeking them.